This is lesson 5 of Precalculus with a textbook by Larson. We're on 1.3 graphs of functions. Okay, we are going to analyze a graph here. We're going to determine A, the domain of the function. Remember, the domain are all the x values. So how far is the graph going left and right? And then we're going to find the range, or the y values. The y-axis goes up and down, so how far is it going up and down? Find the value of x for which f of x is equal to 0, or again, f of x is a fancy way of saying y. So when y is equal to 0, what is x? What are the values of x from part C referred to graphically? E, find f of 0. Remember, that means x. So when x is equal to 0, they want to know what is y. What are the values from E referred to graphically? G, what is the value of f at x equal to 1? So value of f means y. What is the value of y when x is 1? What are the coordinates of the point? What is the value of f at x equal to -1? And what are the coordinates of the point? Last of all, the coordinates of the point on the graph of f at which x is equal to -3 can be labeled. So that's a fancy way to find the coordinate point again. Okay. So on letter A here, we need to know the domain. Again, how far is it going left and right? So to the left, going left, it's going to -infinity. To the right, there's no gaps at all. It's continuous. Continuous means you can draw the whole thing without picking your pencil up. It's continuous, and it just keeps on going to the right. So it's got all the x's covered. So the domain on it is infinite. And I'm going to write it using interval notation. -infinity to infinity. B, want to know what is the range? How far up and down is it going? So you always write it from the smallest to the biggest. So for the domain, the smallest would be on the left, -infinity, to the right, +infinity. So from the smallest, you'd be down here, it's going forever down to -infinity for the y, but then it stops up here at 4, so it's going -infinity to 4. And they have a dot on the 4, so that means that it's included, so you put a bracket on it. Infinity is not closed. Infinity goes forever. That's why there's not a bracket on it. If there was a bracket on it, that means it stops, and that's the end point of it. There's no ending, so you're going to use parentheses on it. Okay, letter C wants to know for what values of x for which f of x equals 0. So again, y equals 0. So when y is equal to 0 on here, I'll use a different color. So when y is equal to 0, that's right here. That gives you the point, notice I counted by 2. So that's the point 2, 0, and -4, 0. So x would be equal to 2 or -4. Letter D. They want to know, what are the values of x from part C referred to graphically? So what is this point called right here and this point right here? Those are called X-Intercepts. Some people also call them zeros. And you could also refer to them as the solutions of the graph. Letter E, find f of 0. Again, that means when x is equal to 0. Well, when x is 0, y is 4. So y is 4. And they want to know, what is that called? Well, that is the y-intercept. Then letter G wants to know when x is equal to 1, where is the y at? So when x is equal to 1, honestly, it's kind of hard to tell from this picture, so we're going to have to plug it into the graph, the equations that they gave us down here. When x is equal to 1, it's going to be the second equation because x is greater than 0, so we're going to plug it into this one. So x is greater than 0 when x is equal to 1. So I'm going to plug it in here. 4 minus x squared becomes 4 minus 1 squared, or 3. So we get to number 3. So the coordinate point from that would be 1, 3. All right, and then we got H. It's the same question. They want to know what about when x is equal to 1, -1. All right, when it's negative, that's this one. It's for all the numbers less than or equal to 0. So it'd be x plus 4 when x is -1. So put the -1 in, and we also get 3. So that gives us the point -1, comma 3. So 1, 3 and -1, 3. Okay, and then on, let's see, that was H. So now we're on I. Number I wants to know, what about when x is -3? Well, when x is -3, again, that's less than 0. So put the -3 into x plus 4. And you get a +1. So you get -3, 1. All right. Okay, the vertical line test. Now, I was talking about this in the last lesson. If something fails the vertical line test, then it's not a function because the x values repeat. And for each and every x, you can only have one value. So like on this picture, we had the point, looks like 1, 2, 3, 4. I don't know, that's not good. That's definitely a 1 there. And that's 1, that's 2. So that looks like that's probably the point 2, 1. And then we also have the point 2, -1. So for the x value of 2, you have two different y values, 1 and -1. For every single x, you're only allowed to have one y. So the x's can't repeat. So anyway, that would fail something called the vertical line test, which means it's not a function. So no, not a function by the vertical line test for functions. And then they write down here what the vertical line test is: a set of points in a coordinate plane of the graph of y as a function of f, if and only if no vertical line intersects the graph at more than one point. So it's a function if it doesn't intersect the graph vertically at more than one point. All right, then increasing, decreasing functions. That's a fancy way of saying the slope. So the slope is positive when it's increasing, so it's going up the hill. The slope is decreasing or negative when it's going down the hill. So they've graphed the picture for us here of the square root of x squared minus 1, and it goes all the way down here to these 2 points. They include both of those points. So it's at 1, 0 and -1, 0, and everything to the right and left there. So anyway, increasing and decreasing are all about the x values. And at the endpoints, it's neither increasing nor decreasing. So, okay, so let's look at the x points. Again, it comes in from -infinity. The x values, they're coming in from -infinity. So going left and right like you read a book, it goes from -infinity to the point -1. And then it's got a gap. That's a hole there. There's no y value, there's no points there at all. A lot of people like to draw a straight line there. There's no line there because remember, you can't take the square root of a negative number. So if you solve that for when it's greater than or equal to 0, you get x is greater than or equal to 1 and -1. So that's why those are graphed there like they are. It's greater than 1 and it's less than -1. There's no numbers in between here. 0 doesn't work. If you put a 0 in there, you get the square root of -1, and that doesn't work. So anyway, focusing, going from left to right, the x's went from -infinity to the x being -1. And what's happening is that the y values are going down. It's got a negative slope. The y values are decreasing, so it's decreasing or a negative slope. And then it jumps over here to +1 to infinity for the x values. So from +1 to infinity, it is increasing because it's going up. So over here it went downhill, and over here it goes uphill, so it was increasing. Then on the next page, if you graph this one in your calculator, let's do it together here. Turn on your calculators. Go up to y equals, clear out what you have in there. So we got x, and then the square root of 3 minus x. And I think my zoom is fine, but we'll just go ahead and start it at standard. So that does a 10-10 grid for you. Okay, so it comes down here and stops at the number 3. And the reason why, again, it stops at 3, because if you set what's under the square root less than or equal to 0, it's going to have to be 3, negative 3 and below to make that a positive number. So that is why. And it was going through 0, 0. And 1, 2, 3. It stopped right here at 3. We kind of need to know what this point is right here. And that's a max, because it's at the top of the hill. And then it goes down. So I'm going to hit second calculate the max. Pick a point to the left of the hill, hit enter, use the arrows to go over the hill, hit enter and enter again. And it tells us our maximum is at the point 2, 2. So the max value technically is 2. All right, but that's where the max is at. So again, going left to right, you're coming in from negative infinity down here on the x's. It's coming up to the number 2, and it was positive. So negative infinity to 2, it's increasing. And then from the number 2 to the number x being over here at 3, 0, so from 2 to 3, it is decreasing. Because it was going downhill. All right, we're going to look at the max and the min on the next ones. So again, we're just going to graph it on our calculators. So hit clear. So we've got negative x to the third, and then plus 3x squared, kind of fun. All right, so we're just going to eyeball it here. So it came down, it looks like it went through 0, and it goes up and then back down. We need to know that point and this point. Again, I'm pretty sure that's 0, 0, but we can double check it here. This is a minimum. It's the minimum point there compared to the points to the right and the left. It's the smallest. It's the bottom of a hill, and went decreasing to increasing. This point's the max because it was increasing then decreasing. So second, calculate the min. Again, take it to the left of the valley here, hit enter. Go through the valley and back to the other side, hit enter and enter. And that means 0. When they say it's some super small number like that, it's 0. E to the negative 7th means scientific notation times 10 to the negative 7th means it's super small. So that's 0, 0. All right, second, calculate the max. Okay, go to the left of it, hit enter, go over the hill, anywhere over the hill, hit enter and enter again. And that gives you the max of 2, 4. Okay, so they wanted to know the relative max or a min. So this is a relative max. And this one over here is going to be a relative min. And let's overachieve while we're on it and do increasing, decreasing. So from negative infinity, coming in from negative infinity to the number 0, it's going downhill. So it's decreasing. Negative infinity to x being 0. And then from 0 to 2, it was increasing because it's going up the hill. And then at 2, it turns around and goes down the hill. It's got a negative slope again. So from 2 to infinity, it is decreasing again because it's got a negative slope and it's going down. All right, let's graph the next one. Okay, graphing the next one, we have 8x minus 4x squared, graph. Okay, so it makes a parabola shape upside down. Looks like it's going through 0, 0 again, so hit that point. You're always supposed to hit the intercepts when you're just sketching it. All right, so we got a max, and that's actually an absolute max because there's no other point bigger than that. You could call it a relative max too, but it's an absolute max. There's no other point on the graph that's bigger than it. So second, calculate the max. Again, a point to the left, hit enter, go over the hill, enter and enter again. And our max is at the number 1. It says 0.9999, that's 1. So 1, 4. And you could check it on the table. And last one, you could have checked on the table too. You can see the 0.14 is on the graph when you look at the table. You could have done that for the last one too to see the 0.24 was on it also. Oh, let's play the increasing, decreasing game again. Let's go for a car ride. We're going up the hill, boom, stop. We're going down the hill. So going up the hill, we've got a positive slope coming in from negative infinity to the x being 1. Again, it's all about the x values. So increasing. And then from the number 1 to positive infinity, it's decreasing. From the number 1 to infinity. Again, there's a parenthesis on the endpoints of increasing and decreasing, because at that point of which it changes from increasing to decreasing, it's neither increasing nor decreasing. So, last page. It says, sketch a piecewise function defined. Sketch the graph of the piecewise defined function by hand. All right. Well, we could do it by hand. All right, graphing it by hand. When x is less than or equal to 2, that means it starts at the number 2, so I'll put a 2 in there. When I put 2 in there, I get, so when x is equal to 2, I'm going to get 1 minus 2 minus 1 squared. So 1 squared is 1, so 1 minus 1 gives me 0. So at 2, it's 0. Well, you know, they said to sketch it by hand. They said we could use a calculator. Let's use a calculator. All right, so going up to y equals, I'm going to clear it out. We got 1 minus parenthesis x minus 1 parenthesis squared, graph. Now when you do this, it gives you more than you want. Again, you only want the piece of the graph that's less than or equal to 2. So second table, we've got that point 2, 0. We already graphed that. And then smaller, because all the numbers smaller than that, we've got 1, 1. We got 0, 0. And then going down some more, we got negative 1, negative 3. And then negative 2, negative 8. So this would be the graph for all the numbers less than or equal to 2. Then we have the square root of x minus 2 for all the numbers greater than 2. All right, I'm going to clear that one out. So we've got second square root of x minus 2. So it starts at the number 2. And we already have a point at 2, so that's okay. And then going to the table, again, it starts at 2. And then another good point is 6, 2. See if there's any more less than 10. There's not. So let's put the last point on there. Let's see, that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 2.8. So about there. It's always nice to leave the graph at about where the number is. All right, so that is a sketch of the defined piecewise function. We could overachieve. I know you want to. The domain on this is negative infinity to infinity because there's no gap. The whole thing is connected. The range on it, again, coming down from down low, it's coming from negative infinity, and it's going up forever. It's not going fast, I agree, but it is forever going up. So the range is also infinite. You could say it's increasing from negative infinity to that point right there. That was the point, I think, let me see, where was that at? That was on the first one, that was on the parabola. So that was a 1, 1, 1. So it's increasing from negative infinity to x being 1. Again, it's all about the x values for increasing, decreasing. And then from 1 down to 2, it's going downhill, so it's decreasing from x being 1 to x being 2. And then from 2 to infinity, it's increasing, or has a positive slope again. So from 2 to infinity, it's increasing. So we got domain range. Let me see. Oh, well, it has a relative max right here at 1, 1. So it has a relative max value at y equal to 1. I don't know. I guess technically it has a relative min value right here, too, at the bottom of that hill. It's got a valley there at 2, 0. We could call that point right there a relative min. All right. Overachievement done. On the next one, even, symmetric to the y-axis. So you got the point xy, negative xy. So if you had the point 1, 1, you got negative 1, 1. The x changes signs. And then when it's odd, it's symmetric to the origin, which means it's symmetric. It flips over the x and flips over. It flips over the y. It flips over both. And so both the x and the y change signs. So instead of 1, 1, you also can have negative 1, negative 1. You just change the sign of both of them. And symmetric to the x-axis, it's not a function. So you can't say it's an even or odd function because it's not even a function. All right, so the last one here, number 70. If you graph number 70, well, let's do it. Because some people have a hard time finding the cube root button. I'll help you out here. So y equals clear. Go to math. So math, and then it's the fourth choice, cube root of x minus 1. And it makes kind of a sideways S when you do it. And because of the minus 1, it shifted it to the right one. So it's going through positive 1. So it's neither even nor odd. It's neither of them. All right, I'll see you for the next lesson.